Good morning, everyone. Thank you so much for joining us for today's webinar, How to Unleash the Power of Data with SAP and Kafka. My name is Joanna Grimmond. I'm one of the marketing managers at Confluent. And before I hand you over to today's two amazing speakers, we're just going to hold for 1 minute to allow the people who are still joining to get set up. And in that time, I'm just going to launch a quick poll for you to respond to. So if you can take just a second and let us know, what do you need to do to unleash more power from your company's data? You've got a few options there to pick from. Okay, I'll give you a few more seconds just to respond to the poll. Okay, so thank you so much to those of you who responded to our poll. Let me tell you the results. So we had 33% of respondents saying we have enough data, but we need better ways to analyze it. And the remaining 67% said our data is collected and aggregated, but we need to connect. So that's where everybody is with what they need in order to unleash more power from their data. So I'm just going to close that poll now. Okay, before we get started, just to draw a couple of things to your attention. In your control panel, you should see a section called handouts, and in there you'll find a couple of pieces of collateral from Confluent, and you'll also find today's slide pack. So please download those if you would like to access them. You will receive the recording for this webinar at the end of about an hour after we finish. So please look out for that. And in addition, if you have any questions, please post them in the questions section of your control panel. And with that, I'm going to hand you over to our speakers. Over to you.
Thank you. Hello, my name is Maria Berinda Tâmpănariu, and I'm a Senior Solutions Engineer at Confluent. At Confluent, we are pioneering a new category of infrastructure to set data in motion. Apache Kafka is the foundation of this data infrastructure, but the open source technology alone is not sufficient to implement use cases end-to-end, particularly for mission-critical enterprise workloads. I am based in the Netherlands, where I work with Dutch enterprise customers who unleash the power of data by using data streaming. They are reimagining their data infrastructure to seamlessly harness the flow of data across all the apps, databases, SaaS layers, and cloud systems in the enterprise. So, how does it work when SAP is one of those systems? That's what we will look at today. Our partner Rojo is an expert in delivering top-notch SAP integration solutions that guarantee businesses the visibility and success they need in their digital transformation journey. Shashank Singh is an enterprise integration architect at Rojo who will share with us a very exciting use case he has worked on. Shashank?
Thank you, Maria. Welcome, everyone. As Maria mentioned, Shashank Singh, I'm working as an enterprise integration architect with Rojo Consultancy. I'm based out of Netherlands. Giving a brief background of Rojo itself, we are a European company with offices in the Netherlands, Spain, and India, operating globally. Our customer base is all over the world, from Argentina, Chile to Amsterdam and Singapore. At Rojo, we focus exclusively on enterprise integration and data analytics. We have been in market for over a decade, working mainly on SAP integration. And talking about our portfolio briefly, our portfolio consists of services and products which cover 360-degree life cycle of integration, from strategy, governance, architecture, to creating and executing any integration project. But what comes after that is managing and keeping the operations 24/7. Yeah. So this was a brief about me and Rocco itself. So maybe we can go to the use case. Yeah. So I'll start with a use case introduction. So in this use case today, we will primarily focus on master data synchronization. Yeah. Most of you who joined understand that master data plays a critical role in business processes of many enterprises, and synchronization of master data with a different application is vital to completeness and correct execution of various business transactions and processes. Yeah. Therefore, organization must have a master data synchronization approach and a strategy that ensures up-to-date master data across their applications. Now, talking about the event-driven architecture and why. Yeah, and to enable this synchronization, event-driven architecture can provide a way to achieve that. Yeah. Now, imagine if you have multiple applications which are interested in the master data maintained in SAP. Having a one-on-one connection with all the application creates a mesh, and there is a very tight coupling between your source and your target application. So, as a good integration design and a flexible model, it becomes critical that the producers and consumers are decoupled. Here, Kafka plays a key role in achieving this decoupled architecture. During this session, yeah, we will share our experience based on the customer scenario that uses SAP as the system of record for material master data, and the SAP application in different countries where that customer is operating, where operations are running, are interested in receiving the latest material master update. Yeah, this is just one use case which we thought might be relevant for the audience here. There are multiple other use cases that we are working around Kafka. Yeah. Now, if we move forward, yeah. So before going into the exact details about the architecture and design positioning of Kafka, let's talk about some of the challenges that were there when we started with the use case. Yeah. Now, here you see high volume. Yeah. Now, these master data requirement for the regional SAP systems the volume was really high. And when I say high volume, we are talking about millions and millions of product master data that are needed by their regional SAP applications. Yeah. And because of this high volume of data, the SAP master data application, which is the source of truth of these master data, is continuously at a very high load and busy sending these updates. And due to these heavy load, the processing time are longer, which in turn means that there is an increased risk of obsolete data being used in the local processes on the regions, different countries. Yeah. So, and as a result of this risk of the data being obsolete, the order management that is happening on the regional side, they face certain challenges. Yeah, there's a manual intervention needed. There's a clarification needed on the data itself, and that poses additional risk and delays in the processing on the region side. Yeah. So these were brief highlights of the key challenges when we started with this use case.
How old is obsolete data? So you mentioned obsolete, but what kind of time frame should we think about?
Yeah, today I think we are talking about obsoleteness of around weeks. Yeah, but in this digital, evolution, I think customers might also say that one day data is also very old. Yeah, so here in this case, when we started it, it was weeks. Yeah, that we are talking.
Oh wow, thanks.
Now going to the integration, now we'll talk about the integration architecture there are different architectures that we built as a part of solution to these challenges, and how Kafka is positioned in between, yeah, to achieve this whole data streaming. Now here in this slide, you'll see on the left-hand side, which is the master data application, where all the master data is stored. And on the right-hand side, you have regional SAP systems, which need these data at a regular frequent interval, so that they keep their applications, regional applications, up to date with the current snapshot of the data. Now here we are using iPass, yeah, to connect to the SAP systems, and in between you see there is a layer of Kafka. Yeah, this is a standard publisher subscriber interface, because one of the approaches was also to keep things as standard as possible. Yeah, so Kafka here in between is playing a role of a broker, and on the left hand side you have the producers, and on the right hand side you have the consumers. So with this architecture, we are decoupling our producers with the consumers, yeah, so that the producers can keep on producing and the consumers can keep on consuming. So on the left hand side, the master data SAP system, whenever there is a change in the material master record, the data is pushed to Kafka. We are using iPass in between to do the connectivity and to get the do all the transformation that is needed, and then the data is stored in Kafka. Yeah, and on the right hand side, the consuming application, the applications which are capable of consuming directly from Kafka, they connect directly to these topics, and the applications which are not, advanced enough to consume directly from Kafka, we have an iPass layer in between to facilitate the connectivity and to do if any transformation is needed in the whole chain. Yeah. Now here you see we are also using an observability platform. In this case, we are using Splunk to track the end-to-end chain of the messages. So here we are logging every event that is being sent from the source and that is being sent to the target. So within Splunk, we have a track of whatever is flowing through the integration layer. Yeah. Now to zoom in into the middle part, which is the Kafka, maybe I'll give a brief about topic for those who are not familiar with it. Topics are buckets or containers, yeah, within Kafka clusters used to organize your message. Yeah, each topic you can have your own unique name to it. Yeah, that is unique to the entire Kafka cluster. So messages that are produced to Kafka are sent to these topics, and messages are also read from Kafka. In other words, producer write data to these topics and consumers read data from these topics. Yeah. Now the configuration of these topics could vary. Yeah, there is a concept of partitions in Kafka. You can have your partitioning enabled. It also have different advantages when you partition your topic. Parallelism is one of them, which you can achieve using partitioning, and your data is also distributed across multiple clusters within Kafka. Yeah. So this was brief about topics in general. Yeah. Now, if I zoom into the middle layer of topics, yeah, these topics are in this use case. These topics are divided into two categories of topic. One is the data stored topic, which is compacted in nature. Compacted means like you can store the data for an indefinite period of time. There's no retention period there. Yeah, and it also stores the latest version of the event. Yeah, it just compacts the older version of the event that was sent to the topic for a given key. Yeah. And then there's another set, which is the delete topic, which are mainly for the consumers, because from there they can read and there's a default retention period and the data gets deleted after that specific retention period. Yeah. Now, it is important here to mention that the data stored topic, which is the compacted is in nature, stores the snapshot of a given material, which is available on the SAP master data application. So whenever there is a change that is happening in the SAP master data, it is pushed, transformed into a common data model and pushed to the data stored topic. So at any given point in time, the data that is stored in Kafka topics, compacted Kafka topic, is the snapshot of the data which is available in my SAP system on the left-hand side. Yeah, and then the consumers get the updates immediately, and they process and update their regional SAP systems. Yeah. So this is the standard publisher subscriber interface that we is one of the interfaces that we built for this master data synchronization. There's another one which is there in the next slide, which is mainly about and this architecture is mainly about the online request interface. When I say online request, this is an on-demand interface. Now, in this architecture, there could be a question: why is an online request interface needed? Yeah, so it depends on the business case. So in this case, the regional ERP system on the right hand side might not have all the data that is required there. Yeah, there could be some materials which are not available. Yeah, because order processing is going on. There could be orders for a different product which is not available within the SAP system. So that's the reason we provided this additional interface, which is an online on-demand interface where the users, the key users on every regional SAP system, they can immediately make a call. If you see point number one, the regional SAP system make a call. Step number two, we look up into Kafka first, yeah. And for this, we are using a Kafka Streams application. I'll go into the Kafka Streams application later on, but this is a REST interface which is exposed via the Kafka Streams application. So we look at the Kafka Streams, Kafka itself for the availability of that data. If it is not there, then we still go to the SAP master data application. Here also from the SAP master data application, I'm talking about step number 3. An interface, online REST interface is exposed, which we make a call to it and retrieve the latest data which is available in the SAP application, and then make a call to a pricing service. There's a pricing service. I think it could be any services if you want to enrich the data here. So this pricing services is called in this case, and then send the response back to the regional ERP system. Now here in line step number 4, after if we have a situation where we have to go and make a call to SAP system to get the data, we are storing it back to Kafka. Yeah, and then returning the response back, so that once the data is stored in Kafka, if a subsequent call comes in for that SAP system, for that material, we don't have to go to SAP anymore. We can retrieve the data back from the Kafka itself. Now here on the Confluent layer, we are looking up at the data store topic, which was there, which I explained in the previous architecture. So this data store topic is being continuously updated by the async interface, publisher subscriber interface. And in this architecture, online request interfaces, we look up into that data store topic to retrieve the latest snapshot of that material, which is pushed by the SAP systems. Yeah. Now here, to talk briefly about the Kafka streams, for those who are not aware of Kafka streams, Kafka streams is a client library, yeah, where you can build your applications and microservices. Yeah. Now, if you have a use case, now talking about the use case, if you have a use case which goes beyond just consuming and producing, and it includes certain complex logic like comparison. One of the use cases could be if you want to compare the data, the current snapshot with the previous snapshot, then you can think about a Kafka Streams application. Yeah. Here in this case, we are using a Kafka Streams interactive query because we wanted to have an REST interface exposed out of it. And that's the reason we are querying the K table that is there in Kafka Streams and retrieving the latest snapshot of the data. Yeah. So this is mainly about this architecture, and on top of it, you see there's still we are using observability platform. Splunk is the observability platform that we are using, and all the requests that is coming in from the regional SAP systems, they are being tracked. So as a maintainer of the integration, yeah, we get a clear visibility of who is making the call, and are we from the integration side, we are responding to these calls in a correct way, or is there any issues that are happening with the call? So we keep a track of everything in this Splunk platform. I'll go a bit more into details on different panels that we are using, but on a high level, this is the architecture.
Before moving on to the monitoring part, I have a question about how it works with the Kafka Streams application. So how were the responsibilities split between Rojo and the customer? Who built it? Who maintains it? How does that work?
Yeah, good question, Maria. Here, for the audience, it's good to know that when you are thinking about a Kafka Streams application, then you need to have the capabilities in your team around Java. So it's a Java application that is needed. So definitely, yeah, expertise around Java is needed to write these applications and then to deploy these applications. So in terms of responsibility, we from Roco, we wrote these applications, and these are being maintained by customers. We are also supporting in maintenance of it, but we build these applications for customers. Yeah.
Thanks. Let's
Okay.
have a look at the
Then
monitoring.
yes, let's go to the monitoring. So basically here, connecting the applications, so your source and sender and the receiver is only half of the challenge. Yeah. It is essential to monitor any anomalies that could hamper the business, because you want to be in a mode where you are tracking these anomalies, and you're the first one to respond to these issues. Yeah, not wait for the business to come back to us saying that okay, something is going wrong. So that's where monitoring plays a key role. And you would also want to have a clear overview of all the events or the messages that are being processed through the integration layer. So we are using an end-to-end monitoring solution in Splunk. Yeah. This is let's go to the next one, Maria. But for the audience, it is a concept. What we are presenting is a concept. Yeah. And we are using Splunk as a monitoring solution, but it's not necessary that Splunk is the only solution that you can use. If you have a different solution as your observability platform defined within the organization, then you can also hook in this concept. Yeah. So here in this is a snapshot of one of the monitoring dashboards that we built at the customer. And this is this is tracking the online request interface that we spoke about earlier. Yeah. Now here you see in different panels how many you can track, how many requests, total number of requests that came in, how many of those requests were successful, how many of them failed. Yeah. If you drill down into the failed message, you can actually see the reason of failures. Yeah. So because that is important when we are maintaining the integration, to understand the reason of each and every failure, why it has happened. And if there is a failure, you can also have a trigger, alert triggered behind it, so that immediately you get a notification that something is not going right in the platform. Now here in the panel on the left, we are tracking the topmost materials for which the request has been sent. You can derive multiple, interpretation out of it, which is the most popular material across the regions, how many times it was called. Then it also translated into a business value as well. Yeah. Now, on the right bottom, there's a panel which is about it's a pie chart which shows division of different consumers who are making the call, and you can see that you have few consumers who are really making a lot of calls than others, so you can track it here. Yeah. Maria, if we go further, yeah, this is another snapshot of the same dashboard. Here we are tracking the different response times. Yeah. So in the online request interfaces, it's important to track what is my response time as an integration, how much time are we investing in the processing. So, and there are multiple applications involved where you might be doing lookups, yeah, as well to enrich the data. So what is the response time of those applications? Because the overall response time is also contribution of different applications in the chain. So here we are tracking all the response times that are there. What is my overall response time for the service, plus the different applications that are involved in the orchestration. You can also see this is just the graphs that we built for the customers, like the number of requests per country. You can see the spikes coming in, then okay, yeah, maybe Singapore started at that time, so we see a spike for Singapore. European regions start a bit later, so you'll see the spikes coming in a bit later during the day. So you can derive certain conclusions out of it. Yeah. And on the bottom, you see there's a trend of response time. So this is a very important parameter. At least you can figure out that during this part of the day, my response times are increasing because maybe there's a heavy load on the system, or my applications involved in the integrations are not performing well. So you can take the corrective measures around it. Yeah. So yeah, you can. So as I said in the beginning, this is a concept. Yeah. Here we are using Splunk. If any customer who are having Splunk, yeah, we can support in guiding you through this process. But the same concept can be applied in any observability platform that you have within your organization. Yeah. The most important thing is the transparency that it brings, and how it could help your integration team to be proactive, yeah, in identifying any issues that might come. Now we spoke about the use case, we spoke about the architecture, the end-to-end monitoring. Now, after the implementation of these new architecture, new design, data streaming, including Kafka and other applications in between, there are benefits that came out of it. Yeah. Now, reduced latency. This is a very important one because now the regional ERP systems are getting the updates more frequently. So their systems are more up to date now. Yeah, which means the quality of data has improved. That means that could in turn could mean that now the key users could have more confidence on the data that it is correct, and because of this there is a less of a manual intervention or less of a discussion around the data, and that increases the efficiency overall, yeah, in terms of processing or the local processes on the region side. Yeah, so these are the benefits, key benefits that we came we derived from after this implementation, and based on the feedback that we got from different consumers of these integrations. Yeah. So this
How interesting.
so, sorry, Maria, can you come again?
I thought it was very interesting, and I was wondering if you found that except of these or in addition to these very tangible benefits, did you find that the customer changed their view towards data? Did you think that anything changed there?
Absolutely, because that's the, I would say, that the byproduct that we achieve after having an these different integration patterns being involved in the data uh, transfer process. Because now, since the data is more up to date, it brings in, as I highlighted, it brings in it increases the level of confidence on the data. So that's the most important thing, because now the local processes are aware on the regional side that they have the up to date data, and they really don't have to worry about the obsoleteness of the data. So perception changes about the data, and we see that more and more requests are coming in for integration using the same approach. So that's the positive side, because these requests would only come if there is a change in the mindset of the consumers. Yeah.
Interesting, especially because that's exactly what we see too at Confluent with our customers. So the new paradigm for data in motion is centered around event streams. So data is not static or passive, but continuously evolving and continuously being processed in real time. So the fundamental notion is of data moving and not being evaluated at a later time, but as soon as it happens. And like you've shown in your very interesting example, Shashank, the manufacturing industry is experiencing a transformation with a ubiquitous rise of instrumentation, connectivity, and Internet of Things technologies powered by data and analytics. Today's manufacturing industry is witnessing the creation of a fourth industrial revolution. By 2025, analysts are expecting that Industry 4.0 will generate greater than $1 trillion in economic value as manufacturing processes, operations, and their supply chains become more streamlined, efficient, agile, and realize improved productivity, uptime, and product quality. This kind of progress can only be realized by harnessing the data and the digital interconnection of all aspects of the manufacturing value chain using the cloud, servitization, and accelerated innovation with, for example, digital twins and connected supply chains. The potential of IoT over the next few years is immense. In the near term, we see manufacturers are leveraging this capability to realize efficiency, but we also expect newer revenue streams and products in addition to the near-term efficiency gains. One of the immediate opportunities to realize this value is by implementing a predictive maintenance solution. This allows manufacturers to determine when any equipment or part will fail, and they can intervene at the right moment to address the issue via maintenance or replace the part right away. An increasing number of industrial asset operators and manufacturers are adding industrial connectivity to their assets. Studies show that 50% of industrial assets in factories will be connected to some form of on-premise or remote data collection system. An increasing number of factories are also opting for end-to-end data collection solutions that bypass the traditional automation pyramid and send data directly to the cloud.
Maria, since we are talking about cloud here, something which question might be interesting for the audience: how do customers deal with the security concerns when sending the data to the cloud?
Yeah,
Because
brilliant
from my
question.
experience, I have experienced these questions from different customers. How do we deal with it with Confluent?
Yeah, so there are extensive security features built into our platform, which can be found on our website or are also the topic of different webinars. But I think one of the main ones I would like to mention is that data is always encrypted. So it's encrypted in transit and it's encrypted at rest.
Great. Yeah, thank you, Maria.
Thank you. So by integrating data streams into business operations, manufacturers streamline operations, they deliver higher quality, more relevant products, and they reduce waste. Real-time streaming data enables manufacturers to modernize existing processes and streamline their costs. Manufacturers can improve traceability on goods, people, assets, and events, increase inventory accuracy and forecast, and reduce risk of fulfillment. You can also augment traditional SIEM systems to deliver contextually rich data for advanced threat detection and security forensics. You can also detect and stop fraudulent activity in real time or route this data to downstream systems such as Elasticsearch or, like we've seen before, in Splunk. You can break down silos across systems and ecosystems to improve equipment effectiveness and predictability. This way, you can prevent breakdowns and reduce costs related to any unplanned downtime or failures. And you can build a digital twin to increase the reliability of equipment and production lines. And with all of this, you can reduce your business risk. So the modernization of the IT infrastructure could take one of many forms, including messaging modernization, mainframe offload, hybrid cloud data pipelines, and digital service at the edge. And last but not least, you can build the real-time dashboards like we have seen in the use case presented by Shashank. And you can use the dashboards to monitor data from sensors on your factory floor, for example, for asset management use cases. And you can merge and enrich data from multiple sources and feed it into the downstream systems, both within and outside of your enterprise. Let's look at a few other examples of manufacturers and supply chain vendors who have transformed with Confluent. Every year, Bosch Power Tools, a division of German industrial giant Bosch, churns out hundreds of thousands of drills, mowers, trimmers, and power saws, as well as more heavy-duty equipment used on construction sites. There's data stored in CRM systems and sales platforms about who bought and registered the tools. Then there's sensor data about how the tools are used in the field. And then repair shops have information about where the tools have failed and under what circumstances. And then there's the data flowing from the production lines. The aim of the Power Tools IT team is to take all this data and combine it in a new way to add value for customers and for the company. Bosch has spent the past 4 years building a platform that's capable of pulling together and interrogating all this data in a way that meets the company's long-term business requirements. Another example is butter. In the food industry, you have farmers, you have transportation companies, you have food processors, and you have distributors, so even more transportation. And then you have the retailers and the restaurants, and then the consumers. And maybe even recyclers who recycle any waste that was developed during or at the end of this process. By capturing IoT event data from farm to fork with Apache Kafka and Confluent Cloud, Butter is increasing its value as part of this chain, creating new business opportunities and enabling its partners to optimize even their operations. We have seen a few success examples from the manufacturing industry, but this is not all. Apache Kafka has been adopted by over 70% of all Fortune 500 companies. Kafka is a great way to get started with data streaming and real-time use cases. Do you see this as well at Rojo, Shashank?
Yes, definitely, Maria, because from the experience we have seen today, we gave an example of manufacturing industry, but we have seen similar adoption from retail industry based on our customers, and also the finance industry. Yeah, so this adoption is is something that is that we have noticed, and yeah.
Interesting. So why are companies adopting data streaming? It's either to remain successful in their industry or to disrupt it, which can be at times challenging, considering all the things that all the unexpected things that have occurred in the last years. Businesses need to create new paradigms leveraging connected data to make better decisions and provide better customer experiences. We've seen this over the last 2 decades with companies like Netflix, Tesla, and Amazon, just to name a few. They took and continue to take in tons of data points about their customers and business processes to more effectively communicate and sell, and also increase efficiencies internally by speeding up and automating processes. This is exactly the problem Confluent solves with a radically transformative approach. The Confluent data streaming platform enables you to construct a unified real-time knowledge base of your customer by tapping into feeds of information as they change. You can take the various data sources and connect them into Confluent in many different ways. You can use our pre-built connectors for commonly used systems or interfaces. Confluent delivers over 120 pre-built connectors, making it easy to read from isolated systems. Turn on a source connector for each, and changes will flow in real time to and from Confluent. You can also leverage the Connect framework and build your own connectors, like many of our partners have, who also make the connectors they've built available to customers. You can also use Kafka clients in various programming languages, or you can use Kafka Streams applications like in the example we've seen at the beginning. Because these data streams usually contain somewhat raw information, you'll probably also want to process the data into a more refined view. Stream processing is how you transform, filter, and aggregate individual streams into a view more suitable for different access patterns. Confluent delivers native stream processing capabilities, including KSQLDB and Flink. And with stream governance, we enable you to establish lineage, quality, and traceability, providing all your teams with a clear understanding of data origin, movement, transformations, and usage. You can track, tag, encrypt, classify, and quality control data on the move with built-in governance, empowering your teams to discover, understand, and trust the data they use. Confluent makes data a first-class citizen, enabling free interoperability of data in real time everywhere, where processing happens immediately and continuously. Data is governed as it moves across the enterprise, meeting the security, compliance, and governance standards of your organization, and it's instantly consumable everywhere it's needed. Confluent's data streaming platform is fundamentally different from many of the traditional data at rest architectures. For one, it's event-centric by design. This means you can capture real-time events and convert them to appropriate embeddings so your AI tools, apps, and models can apply business logic just in time. Our decoupled architecture eliminates point-to-point connections and communication bottlenecks, making it easy for downstream consumers to read the most up-to-date version of exactly the data they want when they want it. Data in Confluent is immutable and persistent, enabling you to aggregate and store all your data infinitely for a single source of real-time truth. This way, anytime you need your data, it can be retrieved, enriched, and reused on demand for all your use cases. Built-in controls for security, role-based access controls, and audit logs enables you to observe your data and deliver uncompromising security, confidentiality, and trust. Safely accelerating innovation and onboarding new use cases definitely requires balance. So, modern governance for a data streaming platform needs to strike a balance in priorities between data users and data guardians. Or, said another way, innovation and trust. It allows businesses to find harmony between protecting and democratizing access to data streaming, in order to expand use of the technology quickly and safely. So Confluent Stream Governance Suite, the only fully managed governance suite for Apache Kafka and data in motion, establishes trust in the data streams moving throughout your cloud environments and delivers an easy self-service experience for more teams to discover, understand, and put streaming data pipelines to work. Stream quality helps you deliver trusted, high-quality data streams to the business and maintain data integrity as services evolve. Then we have the stream catalog, which increases collaboration and productivity with self-service data discovery that allows teams to classify, organize, and find the streams they need. In Stream Lineage, you can understand complex data relationships and uncover more insights with interactive end-to-end maps of data streams. And this is what we mean when we say that we've re-architected Kafka to be truly cloud native. With open source Kafka and other self-managed Kafka services, users are still looking at months or weeks to get started. With Confluent, we provide a true cloud native experience with an offering that is fully managed, elastic, and highly available that helps users get started in just minutes. Our fully managed, cost-effective cloud service lets you scale elastically, is resilient by design, and performant at any load. This means that you can scale up as demand peaks and scale down as demand fails, removing the need for detailed capacity planning and reducing the risk of over-provisioning infrastructure. We offer a 99.99 uptime SLA, automated cluster management, failover and recovery, and advanced controls, minimizing disruption to your business and enabling you to operate your data infrastructure with confidence. In addition to our fully managed cloud service, we offer our solution as a self-managed software and functionality to support hybrid use cases. Cluster linking built into Confluent Platform and Confluent Cloud allows you to directly connect clusters together, mirroring topics from one cluster to another. Cluster linking works by replicating topics byte for byte, including records with their associated offsets, consumer groups with their associated offsets, topics with their associated configuration, and access control lists. And the Confluent streaming maturity curve is used to understand where your organization is on its event streaming journey and plot where you want to go. So it starts at stage 1, where there's early interest and maybe a proof of concept. And then in a second stage, there's an individual deployment, a project with an early production use case. In stage 3, there's a mission critical production use case. So from stage 2, the early production use case has evolved to become mission critical, but it is not connected to other deployments. And once that happens, you reach stage 4, where there's a mission critical event streaming platform with connected lines of business. And in a later stage, Confluent Platform can become the central nervous system for the business, where the entire data is connected and flows through Confluent.
Maybe, Maria, just to add on the previous slide, this is from our experience. This is the journey that we have seen at different customers. They start small, and eventually Confluent becomes the central nervous system of the entire enterprise. So from my experience at different customers, this is what we have seen as well. And also, let's say from the journey point of view, we have seen that customers do start with their own installation of Kafka, but eventually in terms of which is where they are also looking for a fully managed solution in terms of ease of maintenance. They are also transitioning towards a fully managed cloud offering. Yeah.
Thank you. Good. That's good to hear. So what can people who listen to us do now? So if a use case jumped to mind while listening, then you can immediately have a look at how it could work in Confluent Cloud, either by using your existing account or by creating a free trial account. For a free trial account, all you need to do is sign up on our website and you have free credits to take a product tour. And if you're wondering about the cost of such a solution in your enterprise, then you can request a free TCO assessment. We can help you work through what your Kafka setup costs would be and how a fully managed version of Confluent Cloud would compare. Whether or not you are interested in our product, just understanding your own cost structure is a useful exercise, and we can provide a number of cost-saving tips to make either approach better. It takes about an hour and comes with no commitment whatsoever to buy our product or anything from Confluent. And this brings us to the end of our webinar. Thank you so much for listening, and we hope that it was informative.
Thank you so much. We do have a question from the audience, which I'll just read out to you, if you can take a moment to answer it. So here's the question. Is there a limitation to the amount of data that you can stream from the SAP master data using Kafka? Who'd like to answer that?
I think I can take this one, but let's say there's no limitations as such in terms of volume. Yeah. But limitations could also be on the capability. Yeah. If I give an example, if you are integrating SAP systems, then S4 HANA brings in some additional capabilities, compared to ECC. But it depends on your use case. But as of now, I don't see any major limitations in terms of data processing or in terms of volume as well.
Okay, one more question just come in, and it is, what streaming interface was used for the integration of SAP to Kafka? A Kafka Connect connector, custom application, or is there built-in support for Kafka in SAP?
So I can take this one as well. So as I was explaining in the architecture, so for and our idea at that point is to keep things as a standard as possible. So for connectivity, and there was also a need for transformation. So we are using an iPass to facilitate the connectivity with the SAP system, because the iPass sometimes offer standard connectors, yeah, but there are at the same time there are also connectors available from Confluent as well that can be used for the purpose.
Okay, and then one more question. That iPass, could that be SAP, an SAP integration suite, for instance?
Absolutely, yes, that can be, for sure. Yeah.
Okay, do we have any last questions from the audience before we wrap up? No, okay. Thank you so much for that really informative talk. As I said at the beginning, we will send out the recording to everyone, so please look out for that. And thank you everyone for your time and attention today. We do really appreciate it. And with that, I'll let you all go. Thank you. Goodbye.
Thank you very much. Bye-bye.